Hello, I'm a teacher Olimboka Sejuga Masame. Welcome to my YouTube channel Olimboka Physics. We proceed with our sessions with a relativity between fluid motions and the object that is moving in such fluids. And here we are at the case when the fluid is opposite direction with moving object. And here we have velocity of the river as in the direction from the previous sessions, and now the boat is moving against the direction of the river. Okay, as usual, we must have two sets of axes, that is a frame of reference, one for the stationary observer from the ground and other for a moving observer. The observer inside the boat is moving and recording the motions of the boat relative to the river, that is the simultaneity motions. As you can see, we decide to take the moving observer as moving towards left, opposite to the directions of the flowing river, and his axis of coordinate is as you can see here. This observer is always record his velocity with respect to the velocity of the flowing river, and that velocity will be simultaneous because at any positions he will record the velocity that read from the dashboard, and that will be his velocity, and he will never notice any changes from his motions. But the observer from the ground, he will notice a changes of the motions of the boat at this point C. The observer from the ground, he records the resultant velocity. This velocity will be the absolute velocity of the moving boat on the river. The stationary observer will record the velocity of the boat relative to him as Vbg and projected to the vector OB, while he will record the velocity of flowing river as usual vector OA, and the same as along the positive directions. Okay, now we'll have three vector. By using the rules that guide us to draw the vector diagrams, we must have first vector, and the second vector must be drawn from the head of the first vector, which is this one, vector O to O dash. This is the second vector, that is the same that's drawn from the head of the, that is the same as it is drawn from the head of the first vector, while our resultant vector is drawn from the tail of the first vector to the head of the last vector, which is the second vector here now. Okay, from a vector addition rule, we must add first vector, add the velocity OA and OC, which is equal to the resultant velocity OB. As you can see here, we add the velocity of river with respect to the ground plus velocity of the boat with respect to the river, which is equal to resultant velocity of boat with respect to the ground. Okay, we know that as the velocity of the river velocity of the boat with respect to the river will be a negative, then it is minus from the velocity of the flowing river, and the resultant velocity will be less, and it is always negative because it is towards the left. And for the case of displacement, we say that the observer from the ground will observe this boat at a position B, while the observer inside the boat, he will see himself at a position C. This position is not a true position as observed by observer or stationary observer. This stationary observer will see this boat is not moving too faster as a result of this encountering a velocity of flowing river against the directions of moving boats. Hence, for a time taken to reach the required destinations, the boat will take a long time because its actual velocity, absolute velocity, is decreased. Hence, from this concept, this is how we show the general formula that the velocity of object A relative to object B, we take that velocity of A, we minus with B. And for velocity of object B relative to A, we take that velocity of B, we minus with velocity of A. Please like, share, comment. Don't forget to subscribe for more video like this one. Thank you.